Most artificial intelligence tests operate like a contestant on a trivia game show. We feed a language model a static math equation or a multiple-choice question and check against an answer key. But answering an isolated prompt in a vacuum reveals very little about how that model handles an evolving timeline. Traditional benchmarks struggle to measure cognitive endurance, the ability to hold on to a complex chain of logic as the facts on the ground continuously shift. Measuring actual reasoning requires a high-stakes environment. To see if a model can think, we need to force it to make consecutive, interdependent decisions, where every choice ripples into the next over a long duration. Solving a logic puzzle on a blank screen proves very little. Capability is better demonstrated when a model is forced to adapt and survive within a rigidly constrained, continuous ecosystem. The LA28 cricket benchmark adopts this philosophy by staging a 140-over fictional Olympic tournament. It pits two completely isolated language models against each other, acting as independent broadcast desks calling the game in real time. T20 cricket provides the structural complexity needed for this test. Tracking overcounts, run rates, and individual player states across 140 overs requires a massive, constant cognitive load. If a model loses track of the game state, the errors compound. When the AI fails to reconcile the score with the remaining balls, it begins to hallucinate. If it forgets the tournament bracket, it contradicts its own previous predictions. The framework uses a sports simulation to create a psychological pressure test. By demanding consistency over thousands of tokens, it forces a flawed AI to expose its own structural weaknesses. The duel takes place between two competing entities: Desk A, the Southern Hemisphere Sports Network, and Desk B, the Olympic Cricket Analysis Desk. To ensure repeatable results, every API call executes with strictly fixed sampling parameters. The temperature is locked at 0.2. This enforces zero model leakage. Neither desk has any awareness of what the other is saying, predicting, or analyzing. With the external world cut off, both models rely entirely on their own internal logic architectures to process the ongoing match data and generate commentary. By stripping away the ability to course correct based on external cues, the environment leaves the AI exposed. Any failure in reasoning is immediately visible because there is nowhere for the model to hide. The benchmark scores performance using specific data requirements. The Cricket Quality Index, for example, checks whether an AI understands domain logic or is merely dropping terminology to sound convincing. Prediction stability is tracked via a Breyer score. If a model predicts a winner in over 1, but wildly swings to the opponent in over 2, the system penalizes that erratic flip-flopping. The most severe penalty, however, is triggered by hallucination detection. If a model finds itself trapped in a logical dead end and invents a non-existent rule, like a 12-run Super Bowl, the system flags the error and marks the model as logically compromised. These metrics act as a mechanical arbiter. Every logical misstep and mathematical error is quantified, ensuring that model failures are impossible to ignore. While the core test is mathematical, the data manifests through a presentation layer. This includes a 2D stadium canvas engine and transparent broadcast overlays designed for live streaming. The system synthesizes abstract telemetry into a physical environment, producing shot trajectories, boundary graphics, and live text-to-speech commentary from the models. A third independent judge model observes this output to score the narrative delivery and pacing of Desk A versus Desk B. These visuals allow humans to monitor the match, but the actual scoring remains tied to the back-end code where the logical warfare is resolved. The tournament introduces a permanent constraint, the locked prediction. Every claim a model makes in the first over is sealed into an audit log with an immutable run ID. These predictions sit dormant until the 2028 Olympic Games occur in Los Angeles. At that point, the model's synthetic guesses will be tested against the official scorecards of the real matches. This creates an unalterable historical record. We capture exactly what the model was capable of at a specific moment in time, with no possibility of revision. Cryptographic lackluster removes the safety net for developers. There is no way to retroactively tweak a prompt or shift the goalposts once the model has committed to its logic. Moving away from isolated queries toward long-duration, rules-bound duels allows for a more granular view of how language models actually process information. Traditional benchmarks allow a model to work in a vacuum. This environment replicates the compounding pressure of a live event, where one error can collapse an entire chain of reasoning. The test of an AI is not what it can answer in a single prompt. It is how well it maintains that answer over hours of shifting variables and rigid constraints. Reasoning is best demonstrated within these unbending boundaries. It is only through sustained, logical duels that we can separate models that understand their world from those that are simply good at guessing.